Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3352, Foundations of Data Science, Unit 2, topic Describing Data with Averages. Mode. The mode reflects the value of the most frequently occurring score. In other words, a mode is defined as the value that has a higher frequency in the given set of values. It is the value that appears the greatest number of times. For example, in the given set of data 2, 4, 5, 5, 6, 7, the mode of the data is set is 5 because it has appeared in the set twice. Types of modes: bimodal, trimodal, multimodal. Where there are two modes in a data set, it is called as a bimodal. For example, mode set A equal to 2, 2 is 2 and 5 because both 2 and 5 is repeated 3 times in a given set. When there are 3 modes in a data set, that the set is called as a trimodal. For example, in the given set of data, here 2, 5 and data is repeated as a 3 times. So only it is called as a trimodal. When there are 4 modes in a data set, then it is called as a multimodal. Next one is median. Here the median reflects the middle value when observations are ordered from least to most. The median splits a set of ordered observation into two equal parts, the upper and lower halves. Founding the means. Order scores marks from least to most. If the total number of observation given is odd, then the formula to calculate the median is median equal to n plus 1 divided by 2th term divided by observation. If the total number of observation is even, then the middle female is median equal to 1 by 2 n divided by 2th term plus n divided by 2 into 1th term. For example, find the median of the following for the given set of data. Here n number of set is called as n equal to 15. When we put those numbers in the order, that means we have to write lowest to greatest number. So median equal to n plus 1 divided by 2 at the term. So 15 plus 1 divided by 2, you will get the 8. So the 8th term in the list is 24. So the median value of this set of number is 24. Next one is mean. The mean is found by adding all scores and then dividing by the number of scores. Mean is the average of the given numbers and it is calculated by dividing the sum of given numbers by the total numbers. For example, mean equal to sum of all squares divided by number of squares. Types of mean: sample mean, population mean. Sample mean means it is a central tendency measure. The arithmetic average is computed using samples or random variables taken from the population. It is evaluated at the sum of all the sample variables divided by the total number of variables. Formula is x bar equal to sigma x divided by n. Population mean. The population mean can be calculated by the sum of all values in the given data or population divided by total number of values in the given data or population. Mu equal to sigma x divided by n. Next one is averages for qualitative and ranked data. Mode. The mode always can be used with qualitative data. Median. The median can be used whenever it is possible to order qualitative data from the least to most because the level of measurement is ordinal. Next we are going to see describing variability. Range. It is the difference between the largest and smallest scores. The range in statistics for a given data set is the difference between the highest and the lowest for a value. For example, if the given data set from the given data set, you are going to take one highest value and one lowest value. In the given data set, 10 is the highest value and 2 is the lowest value. So 10 minus 2 equal to 8, you will get the answer. Next one is variance. It is a measure of how data points differ from the mean. A variance is a measure of how far a set of data spread out from their mean value. Here the given formula is variance. Next one is standard deviation. The standard deviation is the square root of the mean of all square deviations from the mean. That is, standard deviation is equal to root of variance. Sum of squares. Calculating the standard deviation requires that we obtain a value for the variance. However, calculating the variance requires in turn that we obtain the sum of the square deviation scores. The sum of the square deviation scores are more simply the sum of squares symbolized by SS. It is a formula for sum of squares. The next one is sum of squares equal the sum of all square deviation scores. You can reconstruct this formula by remembering the following three steps. Subtract the population mean from each original score x to obtain a deviation score x minus mu. Square each deviation score x minus mu the whole square to eliminate negative sign. Sum all square deviation scores sigma into x minus mu the whole square. Here in this formula it shows variation for population, standard deviation for population. Next we are going to see sum of squares formulas for sample. Using this it can be substituted for formulation notation in the above two formulas without causing any essential changes. Degree of freedom. It refers to the number of values that are free to vary given one or more mathematical restrictions. It is a sample being used to estimate a population characteristics. Degrees of freedom are the number of independent variables that can be estimated in a statistical analysis. These values of these variables are without constraint, although the values to input restrictions on other variables if the data is completely with estimate parameters. Degree of freedom, short form DF, the number of values free to vary given one or more mathematical description. Here we have the formula for degree of freedom, DF equal to n minus 1. Interquartile range, short form is IQR. It is simply the range of the middle 50% of the score. More specially, the IQR equals the difference between the third quartile and the first quartile, that is after the highest quarter and the lowest quarter have been trimmed from the original set of scores. Since most distributions are spread more widely in their extremities than their middle, the IQR tends to be less than half the size of the range. Thank you.